Chapter 9, Observational Evidence. The James Webb Space Telescope is a remarkable feat of engineering. It is 100 times more sensitive than the Hubble telescope and 2.5 times the size. The beast weighs more than 13,000 pounds and had to be deployed in space after launch. Interestingly, it doesn't even orbit Earth, at least not directly. It orbits the second Lagrange point, which sits at the balance point between Earth and the Sun. The mirrors are constructed as 18 hexagonal segments made of beryllium, each coated with a thin layer of gold. The sun shield has 5 layers of kapton, each only as thin as a human hair, but together capable of blocking 99.9999% of the sun's radiation. The telescope's infrared capabilities enable it to capture information from across the universe. The data from it has been disruptive, to say the least, as many of the observations are not in line with Lambda CDM predictions. Surprise, surprise. The most obvious issue is the sheer number of large galaxies found at very high redshifts. These galaxies should not exist within Lambda CDM paradigm because they would be older than the start of the Big Bang. Before the JWST launched, the expectation was that galaxies at redshifts beyond z=10 would be exceedingly rare, faint, and inefficient at forming stars. Based on Hubble and Spitzer data, researchers predicted a steep decline in the number of bright galaxies with increasing redshift. For example, Bowens concluded that the UV luminosity function decreases by 1 order of magnitude from z to 8 to z to 10. Forward-looking survey plans reflected these expectations. The JADE's mock catalog projected 10s at z is less than 10 over the full 236 arc-minute squared footprint, while the Sears team estimated their survey would find just 5 to 50 galaxies less than z=10. In short, the early universe was expected to be dim and sparsely populated with luminous galaxies. But that is the exact opposite of what JWST is finding. Here's a sample of high redshift data coming from the telescope. And this is just a list of sources of these highly luminous, large, massive objects at high redshifts. There's lots of examples. In addition to the JWST findings, several objects appear to be older than the universe according to standard Lambda CDM timelines. While many of these redshifts or age estimates remain uncertain and model dependent, the sheer volume of such objects adds to the camel's back. Below is an additional list of objects with ages that push the current timeline. And so this is just a list of objects that are 13 billion years old or older. So you have Maisie's Galaxy, GNZ11. I'm not going to read all of these, but these are all around 13, 14 billion years old. And for one, nobody would ever publish anything that was like 30 billion years old. But nobody's ever going to publish anything like that. And so these all have a maximum age of around 13, 14 billion. Methuselah is 14.5 billion year old star, and it's relatively close. Recently, David Kipping appeared on the Joe Rogan Experience. Kipping is an astronomer professor at Columbia. On that podcast, Kipping defended the Lambda paradigm against the JWST findings. His defense was that our understanding of galaxy formations is inadequate and that our models for galaxy formation need to be adjusted. The interpretation is disappointing but typical for the field. Every time a new anomaly appears in Lambda cosmology, it's countered as a discovery instead of a failure. Here's an example. The universe appears to be expanding, which appears to violate the conservation of energy. The discovery is that there's a mysterious and unknown source for the energy. Here's another example. The anomaly is the rate of expansion appears to be accelerating. The discovery is, there's a mysterious and unknown source of energy for the acceleration. Here's another example. The anomaly is many galaxies have flat or rising velocity curves. And the discovery, there is a mysterious and unknown source of mass. Here's another example. The anomaly is The JWST is finding a large amount of bright galaxies at high redshifts. The discovery is that galaxies form much more quickly than we thought. The anomaly, data from the CMB, does not match expectations from the Big Bang. And the discovery for that is that there was a period of inflation in the early universe that accelerated the universe at a rapid rate for a brief period. I could go on, but you get the point.